Hey guys, welcome back to another video. Today I'm going to be showing you like the example of this the oscilloscope project in Scratch. It's basically a frequency generator, but it has an oscilloscope to view the frequency. So I'm just gonna name it test 2 because this is just a temporary project I'm going to keep because I already have the original project. So for this, we're going to have to hide the sprite. We don't need this dongle thing, or what do you call it? I don't know what you call that. Don't need an outline. And we can just change this to be an all black costume. Doesn't really have to have a color. Yeah. And I'm going to put my mouse here, hold shift, draw it to be at least 4x4 pixels. I said 5x5. Says the 4x4. Why is it still saying 5x5? There we go. It don't have to be precise for 4x4 pixels, but it need to be around that size. Okay. Name this render. Double click key. Okay. And then make a new sprite. This will need a show though. This is going to show the frequency. Make this red because I'm going to draw like a ball. Well, I need that bigger. Gonna hold Alt to keep it centered while making it bigger. Well, that's a little too big. Dang it. Make that smaller. That works. Make this size equal again. So there's the dot right there. And I'm going to set this to, I'm going to set it to 235 by -165, and then you click. Oh, it's a little bit too off. 225, not 235. There we go. In spot. So now we can go back to the render. Wait, never mind. Before we do that, we need to draw our oscilloscope background. Switch this to bitmap. Go here. I don't want no red background. It's going to be hard to see. Make it black. And I think it's going to mess up your eyes staring at that red, because it's going to be like a strange solid red. Need this to be white. Move this to 4. And this is the hard part, actually drawing a straight line. Oh wait, I could do this. Never mind. I forgot I could hold. Nope. I need to drag that over to the center. And then I can just duplicate it. And then rotate it. There you go. Yeah, since we're on my computer's hot. Dang it. Oh. What the heck? You see that line just escaped? There you go. And I'm going to convert to bitmap and then back to vector again, so that this is grouped together as one whole piece. There you go. Now sometimes, every once in a while, you might need a picture backdrop because it will sometimes go off center. It just it doesn't always do that. It sometimes do that. Go to your render. We're gonna have to make some variables. You need to delete that variable. We're going to have to make one called res. No, not with a lowercase s. There you go. It had to be for all sprite. Make this a slider. And then change slider range to be 1 to 8. There you go. Now this is one of the projects I keep getting confused on. Okay, we need to make a variable called wave. This is actually draw the wave. This could be for this sprite only. I don't know why I said it for all sprites. And make a variable called frequency. We need this to be all sprites because we need to be able to use it in this sprite too. Actually, this needs to be named frequency. Frequency. The reason why we had this frequency ball here, because this is the ball that's going to blink on and off, kind of like what you see on a camera when recording. So we're going to have that there. Go back to render. I hope I didn't mess with the code anywhere. Okay. And this frequency also needs to be a slider. And then change frequency length from 1 to 30. Can't be 60. There's a reason for that. And we're going to put this on 60 FPS. You can do that by holding Alt and green flag. Yeah, hold Alt and click the green flag. It'll put it on 60 frames without starting the project. I mean, the project wouldn't really start anyways because we don't have code. Yeah. And now we need to make one called amplitude for all sprites. And make this a slider. Put it over to the right. And then change the slider range from -12 to +12. Well, I did it like that so that the values don't go too high above 100. Yeah. I don't want the values to get too high above 100 because this will like we need to be able to calculate the division of like the sound and all that. I'm gonna just save this to my computer real quick. There you go. So that the files don't corrupt just in case that the app crashes. It will sometimes crash out of nowhere. Now this is one of the tricky parts about the code, is when you're actually making the block here. So when you're actually making the definition for this block to actually draw the wave, it's kind of tricky. So we're going to make a block, naming it render sine wave. Oh, I almost click enter. You have to run without screen refresh and then hit enter. That did not work. There you go. Now I got this block. And I forgot to add something. What is world? Okay. And you need a pen extension because we're going to have to draw the sine wave. Put this here. Yeah, I'm just doing this for right now. So I can just click that. And the reason why I like to run it without screen refresh, because it makes it really fast, and it will just finish the code without updating the screen. So it just gets done like instantly, because without screen refresh you just see that the line just drawing is like very slow. Yeah, I'm gonna end up putting the res to 4. So we're gonna set our variables. We're gonna have to set our variables here. Set amplitude to 5. It just makes it look cool and make it look like a normal wave right there. And then we'll have to set res. We'll have to set res to 4. And then duplicate this. Set frequency to 1. So you can see the variables are now set. Yeah. And you can also add some controls with your keyboard to change these up and down. Just make sure you put limits to them where they don't go above the max or below the min. Yeah. It's a little bit weird. And then we need to be able to set wave to 0. Because the wave is kind of like the index of drawing. But we call it wave because this will actually be used in the sign of and in the direction input would just be the wave variable, because it's pretty much creating the wave itself. Wait, oops. Okay, what am I doing? I forgot the repeat loop. So the repeat loop is going to have to be repeat. Now we're going to have to do like the 360 times 4. So that's 1,400. 1,440. So 1,440 divided by res. because we're going to have to divide the repeat times by res, so that, well, even though it makes it a little bit more jittery looking, but we have to have a resolution variable so that it would be optimized for the speed of your device, because if you make it too high quality, it's going to really slow down your device and cause so much lag. And my computer's already heating up just from the camera. I don't know why. Is this camera too much quality? I don't know. I mean, my camera's normally 720 pixels, but since it's like this small, it's still trying to render that 720, the same resolution, but it's trying to render it at partial pixel. So I'm not sure if this computer's going to calculate that properly. Yeah. Now the sign of direction could put a huge load on it, but we do need, well, since it's only just one sign of direction block, there's not really a whole lot. So change wave by hold on, let me open this real quick. So this is my other thing. So change wave by frequency times 0.25 times res. Go back to this other piece here. Hold on, let me just minimize this. No, not equals. There you go. Hit the wrong button. So drop into multiplications. So we need frequency. Um, 0.25. I think that's right. Ain't it? Yeah, it is. So I make sure I put the right bubble there. And this is what you want to set the Y to. Set Y to the sine of wave times amplitude times 10. And there's a reason why the amplitude has to be a huge value. Okay, so I'm going to set our Y. Okay. Okay. Drag this, change it to sine. This will make the sine, this is actually what makes the sine wave. So grab wave, put it in here, and then we need amplitude. Amplitude times 10. There we go. Well, the reason why I made this amplitude thing kind of small, because it'll be easier to drag without messing up like a partial percent on the screen. And also the amplitude variable could actually be 12.0 and like negative 12.0 and 12.0. The reason why we add the decimal in that, because it makes it where you can slide the slider in decimal percentages, so that you can increase it by like 0.5 or higher, something like that. And then you can see here that this will do to set Y to do the sine wave, and then to change X is kind of complicated. This is what does the resolution here. So change X by 1 times res divided by 3. It's not really that hard, it's just kind of like tricky to actually think of sometimes. I could just do this here, like swap the positions of res. Can just duplicate this. There you go. And now we can just pen down here and then pen up here. Move that. No, I grabbed 2 pen ups. What the heck? Okay. There you go. And I also forgot a block. We need to set the X to negative 240, but the reason why we put the Y back, because sometimes the Y will get a little offset, so we need to set it as well. There you go. And now if we run it, you can see it's a full wave right there. Now let me just add the forever loop. And you can see here that the frequency will just change. the res will also change. So when you go to like high frequency, it looks like a square wave. That's just because of the resolution, but that's fine. And also the amplitude will make this look like that, and I like how you can just flip-flop it. Oh, it's kind of hard to set it when a decimal. I accidentally clicked a number. Okay. So since we got this set, go in here. Now we might need it. Now we're probably going to add sound to this, but before we do that, I'm going to have to add this, and then going to have to add like we're going to wait 0.49 because we're going to have like the little sound variables. That's going to take 0.01 of like 0.01 of a second, so it's going to make this balance to 0.5, which is a half a second. And since we're going to have two of these, it's going to equal to a second. So we're going to have to add a show. Going to show this, and then we're going to hide it. And when we're on Turbowarp, you can just select it right away. If you're on just normal Scratch, you have to move the show. You have to, when you duplicate it, you kind of have to remove that show block to replace it with the hide block, and you drop it in here. There we go. Now we can add an extension called the music extension, and here we can wrong thing. We want to use this drum thing because it sounds normal. Actually, be able to hear it. Yep, it sounds like that. So 0.01 makes it actually hearable. And then just duplicate this. To duplicate just only one block on Turbowarp, you need to hold Control Alt and then drag. When you want to duplicate you want to duplicate the block on your mouse and all of them under it, then you would just hold Alt. Like this is what it does when you hold Alt, and this is what it does when you hold Control and Alt. Yeah. And you can see this right here will add up to make this 0.5 seconds. So this is what it's going to do. Yeah. And we need to divide that by frequency. 0.49. 0.49 by frequency. We need to divide it by frequency. There you go. You need a really fast computer to be able to actually get that sound quality high, you know. Now, on your device, it might actually go to 30 hertz frequency, you know. But we actually made an oscilloscope. Yeah. And there's another thing we can do for the amplitude. We could do like the sound deal. Just get this here, and then we need a repeat loop. Not a repeat loop, forever loop. And this is the reason why we're doing a separate one, because it's gonna kind of mess up on the weight, on like the weight blocks. It's gonna like really mess up and delay so bad. Oh wait, the sound blocks actually. Not change set volume. Okay, so let me just pop up this page here. See here. Figure out what the frequency was set to. I also made it where you can't hear it or show it when it's in certain frequency. So we need to set it to the absolute of amplitude times 25 divided by 3. That would work right there. So the reason why we're using the absolute value, because remember that the amplitude can go negative, but the sound cannot go negative. Okay, so we need to be able to do this. Okay, so we need to do something like this. 25 divided by 3. So you can see it's at a small value. When you put this all the way up, it should just stay 100. Yep, there you go. So that's the precise math right there. You need like precision here. And now we have the volume. And we can fix this up to where you can only be able to see the flashing dot when the amplitude is above 0 or under 0. So we can do that by grabbing a not operator, an equal operator, set the right side to 0, and then grab the amplitude, and then drop in the left input. There you go. And this is what we're waiting for. It's a working oscillator, and you can also change the resolution, you know. And the sound works too. Look how high look how big that sine wave is. Pretty cool, huh? Yeah. It's like it just makes things sound like that. And I like how you can make the sine waves pretty small. The sine wave actually looks pretty high quality when it's like this though. And you can also invert the waveform too. Now, you can't reverse the sound of the speaker. I can't even fix that perfectly for some reason. Yeah, it's just hard to do that. You know, instead of actually making this amplitude thing decimal, gonna have to remove the decimal. There you go. Now that should work. Yep, now you get precise peaks. And the thing does not blink when it's 0 like it's supposed to, because there is no amplitude. Yep. So this is a real sound check. This is a real frequency generating oscilloscope. 1 Hertz. This is 1 duty cycle, and this is 4 Hertz on 2. You can see there's 1 duty cycle and 2 duty cycles, so that's 2 Hertz. 2 cycles, 4 cycles, and yeah. So this is a very precise one. And this right here had to be very precise too. Like the rendering is, the precision is basically this X thing right here. Since, you know, if you just play with this input, like if you put a wrong input, that's what it's going to look like. Dang it. There you go. So now this is what it's supposed to look like. Now the only part that needs to divide by res is basically this repeat loop, and the other part just multiplies by res, and there's just a reason for that. Because since you're using smaller chunks, you need to multiply it by res, and you need to multiply these by res to make like a chunkier movement to slow down the quality. Not slow quality, I mean like to lower down the quality, and then to speed up your device. So yeah. You can also tell my hair looks different too, because I got it like shaped down some. Yeah. It looks good, doesn't it? And also, in this backdrop here, I could also like add a square here. Let me just make that like a gray. And then make this part a little bit brighter. There you go. And then I'm going to just draw it right here. There we go. Oh, it actually fits perfectly right there. And I'm going to convert it to bitmap again, and then back to vector. There we go. And then I'm going to add an F right here to represent frequency, or I could just say frequency. It doesn't have to be an F. I could just put the whole word frequency here. So 3 frequency. There you go. Make sure it's not interrupting with that ball. Right there's good. Move it down more. Right there's perfect. What about a little bit more up so that Q fits in there better? There you go. That's good. Gonna convert it to. Let me just convert it real quick. So that I'm trying to make it to where it's all one piece, to have them all grouped together so you don't actually drag just one of them. And I kind of don't know why this slides to the left a little bit on some reasons here. It's just when you full screen it doesn't look like that. Yeah, it just, I don't know, the computer isn't that precise of like seeing it in the wrong resolution. You can kind of see that that it looks kind of steppy a little bit. Yeah, and you can also make it where you can't see the steppy movements at some point by just setting the pen size. So let's go. I want to set the pen size. Set pen size to 1 times res. Well, you can play with these values if you want to. Well, actually 0.5. There you go. Well, it's not as perfect. What about this? Instead of changing it by res, we're going to have it set to like a constant rate here, too. There you go. 3. And 4. See how it looks. Now let's see what it looks when the frequency boosts. Okay, it doesn't mess around with the frequencies really. But look how crisp it looks when you put it down to 1. That's what we're talking about. Looks like a perfect wave. Now don't mention about the square wave there. But you can see the waveform better. I'm going to make this look like I'm going to make this the same size as these lines here. Now you can barely tell that stepping is there. Now you can really tell when it's like that. That's just because of the resolution. You can even tell the stepping is there with 4, but until you do that. Now 2 is usually my default resolution. Put it on in 1. You can see the wave very clear now. Yeah, and there's a reason why we put it on 60 hertz. I mean, I'm not 60 hertz, 60 FPS. There's a reason why we put it on 60 FPS and 30 frames, 30 hertz in the frequency deal. Because putting it on 60, it won't go above 30 with sound. Yeah, and my computer just wouldn't produce the sound higher than 15 hertz when recording a video. It just, like, it slows down trying to do that. So on your computer, it would probably work better. So I hope you enjoyed this video. Smash the like button, press the subscribe button, press the bell to get notifications, and I will see you next time. Bye.